Data preprocessing is the most important step in the machine learning pipeline that takes raw data and transforms it to be used in other pipeline steps, like fitting a machine learning model. Why do we need data preprocessing? Machine learning models learn to find patterns from the data that they are trained on. For this, we need to provide datasets that our model can learn from. If we provide the models with some arbitrary random noisy data, which is the case in most datasets in raw form, we will get an arbitrary output as a result. In other words, garbage in, garbage out. Due to this, it is important to have data that is consistent and standardized so that our machine learning models can learn to understand and interpret the input data to provide accurate predictions. There are many reasons for data preprocessing. For example, we might want to clean our data. You might have to face uneven ranges of value. Different data might have different ranges of feature values. It will be hard for models to really find a pattern rather than learning noise from the data. We can either scale the data or normalize it. Some datasets have mismatched data. For example, different units or different types. There are also datasets in which there are missing data. For example, missing frames in audio or video data. So you might also have to convert categorical data to numeric data. Inputs and outputs of models are often numeric values, so we have to convert categorical data to numeric values before feeding them to the model. We often create one-hot vectors. For example, assume the data is in the 4th class and there are 6 classes in total. The category of the data is 4. However, the one-hot encoding will be 000010. One of the most important parts of data preprocessing is data augmentation. Data augmentation is a very useful trick for you to create robust machine learning models. It is a technique to artificially increase the training dataset by creating new data from the existing data. In this case, with more data, your model is more likely to learn the right pattern of the task. However, this is only used in training but not on evaluation. For different type of data, there are different ways of data augmentation. For example, for audio data, you can do noise injection, in which you add Gaussian or random noise to audio datasets to improve the model performance. Or you can do shifting, by shifting audio left or right with random seconds. You can also change the speed or change the pitch. There's also one way called spec augmentation, where you mask some lengths of time steps or features. For image data, you can do geometric transformations, in which you can do flip, crop, rotate, stretch, or zoom. You need to be careful about applying multiple transformations on the same images, as this can reduce model performance. There are also kernel filters that you can change in image data. You can randomly change the sharpness or blurring of the image. For random erasing, you can delete some part of the initial image or mask them. There are also mixing multiple images, which is called mix-up, by blending and mixing multiple images.